So today we'll be using a task to help us review what mean, median, mean absolute deviation, and interquartile range are. All right, so we're going to use this exact same example for a few problems, okay? So it says Mr. Turner has two math classes. With one class he lectured and the students took notes. In the other class, the students worked in small groups to solve math problems. After the first test, Mr. Turner recorded the students' grades to determine if his different styles of teaching might have impacted student learning. So here's the results for their test for class 1. And here are the results from their test for class 2. It says analyze his student's grade by calculating the mean, median, mean absolute deviation, and interquartile range. Which class do you think was the lecture and which was the small group? Why? Okay. So before we even begin to answer those questions, let's go ahead and calculate. So if you recall, the mean is actually the sum or adding up all of the numbers and then dividing by how many there are. So the mean is actually adding up all of these numbers and dividing by what the total amount. And again, the mean is equal to the sum of the terms divided by the number of terms. So let's do that. For class 1, I'm going to use a calculator, of course. I hope you have one too. You can use a phone, your computer, calculator. But if I just plug 80 plus 81 plus 81, dot, 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 add them all up, I get a sum of 1587. And if I divide by how many there are, there's 20 of them. I get 79.39. So the mean for class 1 is 79.39. Class 2, I add them up again, 70 plus 90 plus 80 plus dot, 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 keep going. I get 1692, and the total amount again is 20. And I get 84.6. Here's a common symbol for mean. So the mean for class 1 is 79.39 and the mean for class 2 is 84.6. So that leads us into mean absolute deviation. So what is mean absolute deviation? So mean absolute deviation is, well not what is it? First, let's talk about the actual formula. So the formula for mean absolute deviation, I didn't want to trip over myself too much, so I went ahead and typed it out. But mean absolute deviation, or sometimes they refer to it as MAD, because that is the acronym for M.A.D, which is this formula here, is the sum of each value. So this X represents each value, and this is supposed to be my symbol for mean. It might not look like an actual sigma, but that's what it should look like. But subtracting each value from the mean, and I take the absolute value, I sum those up, so this symbol is for summation, divided by the actual number of values, which is n. And mean absolute deviation is actually, it tells us how far on average all values are from the middle, and the middle is the mean, right? So, or it doesn't necessarily have to be the middle, but it's the mean. So it is the mean of our values. Okay, so I broke it up into the different classes because I think it might be a little much to have it all together. So let's get started. So we'll do 80 minus 79.35, 81 minus 79.35. Another 81. Minus 71.35. And a little magic. I know you didn't want to see me writing down each one, so I went ahead and did it. So this is the absolute value, and just showing you what I did. 80 minus 79, which is the mean, 79.35, and it gives me the absolute value of 0.65. Absolute value shows distance, so it's always going to be positive because I can never go through negative 3 miles down the street. So if you think of absolute value in that sense, that's why it's always positive. So again, I get 0.65. 81 minus 79.35 is 1.65. And so on and so forth. Notice when I get to the negatives, I always get a positive value. So the absolute value of negative 4.35 is 4.35. And so on and so forth. So I did all of the values here are all here. You can check it. You can pause this video to check to see if I did it correctly. I believe I did. And I got a total of 77 when I added them all up. So I'm taking all of these values that I have here and I'm adding them up and I get 77. And then again, remember, I divide by my amount that I have, which is 20. We already figured that out from the last one. So it's 77 divided by 20. And so for class 1, my mean absolute deviation is 3.85. So that means on average, each value is about 3.85 points away, or points, because we're dealing with points for a quiz or a test. 3.85 points from the mean value. And the mean value again was 79.35. All right, let's do for class 2 now. Again, the exact same concept. Okay, so I went ahead again and put the information in so you don't have to see me typing it or writing it all out. But again, I just took each value or each exam grade and I subtracted it from the mean that we got in the previous slide, and it was 84.6. So that's 70 minus 84.6, which gives me a negative 14.6, but I need the absolute value of that, so it's going to turn out to positive 14.6. And again, for the next one and the next one, all of these values are positive because I am doing the absolute value. When I add them all up, so I take each of these values and add them up, I get a sum of 65.6, and I divide that by, and this is I'm going to put over here MAD for mean absolute deviation, divided by 20, and I get 3.28. So that means on average, each exam score is about 3.28 points from the mean on average, from the mean value of 84.6. All right, so let's go on to the median. So again, the median is one of those things where in order to find it, you have to have your values in order. So I have to put the values in order from the least to the greatest in order to find the median. And I've done that here. Oh no, my 90 is not where I want it to be. All right, so class 1, here's my values. And these are the exact same values that are here. They're just in numerical order. So from the least to the greatest, from 70 to 90 here, from 70 to 90 here. All right, so how do we find the median? There's multiple ways of doing this. I want to find the number that's in the middle. So the one of the ways that I do it is I count. There's a way that you can count. You can divide. There's 20 values. So I know it's going to be 2 values in the middle. So let's count going from the top to the back. So that's 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9. And so that means that these 2 values are my median, are the values that I will need to find the median. So whenever you have 2 values in the middle, you take these 2 values, you add them up, and you divide by 2. So again, not every single time. If I have an odd value or odd data set, then I will have one number in the middle, and that will be my median. But because I have two numbers in the middle, I am going to add those two numbers up. So that's 79 plus 80 and divide by 2, and I get 79.5. So again, I'm going to do 79 plus 80 divide by 2, and that gives me 79.5. All right, so let's do the same thing for class 2. We know it's the exact same method. It's going to be the middle two terms. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, and here are my two middle values. So I don't have to do the add them up because they are the same number, right? So 86 plus 86 divided by 2 will give me 86. So the median, for class 2 is 86. All right, the next one is the interquartile range. And I'm actually,